talk about your current assignment in the tutorial. We're going to talk about your next assignment now. So what I need you guys to do is to start getting into teams of 3, except for the 3 engineers. You guys can get into a team of 3. If Patrick's around, just contact me, just so I know if you're still doing it. Do you know if Patrick's dropped out? Okay. Where can I draw that they can see? I can draw from, is it flipped? If I write this, you guys, is that backwards? It's around the right way? Can't see it? Hang on, I'll get a bit of pen. Can you read that? Hands up, like thumbs up if you can read it. Okay, and it's backwards or? Oh, whatever, it doesn't matter. Okay, so teams of 3. And what you guys will be doing is you'll be designing a building system based on inputs that I provide you. So you guys don't really get to decide the core geometry of this building. I'm going to be delivering some of that to you, and we'll talk about maybe we'll talk about that in the second half of this lecture. Let me just double check. So yeah, that's still recording. Good. So cool. So team member 1, team member 2, and team member 3. Yeah, there we go. Team member 1, team member 2, and team member 3 are all going to be working on different aspects of a building. Okay? Now, there are some significant ones that are going to matter. And they're also going to range from being very hard to like mediocre difficulty. And so the mediocre one, and we'll assign that to team member 1, will be a facade. So that's, if I look at, these guys aren't going to be able to see. So if I have a massed building, then this part here is the facade. That involves laying out where there is glazing versus where there isn't glazing. That involves deciding if that glazing is like how it's patterned and how it's spaced, and if it's got shading elements, because we don't want the sun to be directly coming into our building potentially. We're going to work on a commercial building just to simplify all of this. Okay, that means it's an office building. Every level has an office floor plate on it. Okay, so that is the facade. The second one, most difficult one, is going to be the roof. The roof designer has to consider the structure that goes into that roof, how it stands up, how water gets off of it, what belongs on that roof. So, what actually lives on a roof other than, roofing materials?
Water.
What else?
Solar.
Yeah, solar panels. What else? Huh?
Ventilation.
Yeah, so the services that you suck air into the building, or you usually have your water tanks up there, your hot water tanks, all of those types of things, they live on the roof. So someone needs to start thinking about where that stuff lives, and maybe your roof might even be inhabitable. So is there going to be a roof garden up there? All of those types of things could need to be sort of wrapped into a script. And then team member 3 gets probably the most difficult challenge, which is floor plates. And so floor plates. So floor plates includes the location of fire stairs and lift course. Okay. Now buildings need their fire stairs to be in specific locations. I was meant to teach you guys a lot of this stuff last term. Does anyone actually know how far? I imagine the engineers might know, but I don't.
50 meters or something.
It's 40 meters. You need to be at least 40 meters away from 2 fire escapes.
It's in the BCA.
Yeah.
I usually just
So there's it's really an exercise in taking a shape and saying, where are we actually going to put this stuff? And a human in the regular design environment makes that decision. They say, okay, we're going to throw a lift cord here. We're going to put 3 lifts in. We're going to throw some services in there. Bam, done, right? But you might also need a fire stair over here, depending on if your building starts getting bigger and bigger and bigger, right? Because those conditions for how things get spaced start getting more complicated. All of these 3 aspects have really broad and extendable approaches to them. Like I can design a facade that does like a fairly square grid using standard panel sizes, and I'm done, right? I could finish that assignment tonight, and I'm sure some of you could do that. So what I expect of you guys is to push your boundaries as far as you can, because there are people here that need to push themselves out of being a basic grasshopper designer to an intermediate, and there are some people here that are intermediate and push themselves, and there are some people that don't know grasshopper at all. So that's that's why it's vague, because I want you guys to be pushing yourselves. And I know the code students enough. I can look at your assignments from last year to know what where you've come from. So I really expect you guys to be pushing yourselves. You know where you are and you know what you're pushing. These 3 things are all things that can be analysed. Okay? Just placing your floor plates, laying your floor plates out, something can be analysed to decide whether or not that design was a good one. And so what ends up happening for assignment 2, part 1, is that each of these team members designs the script that produces the facade, the roof, and the floor plate. But a different team member for assignment part 2 does the analysis. Right? What that means is you are analysing stuff that you did not make. And I guarantee you that is the most relevant thing you will learn for your career going forward, is working with stuff that you didn't make. Because that's what I do every day. And that's why I think this is good group work, because rather than you focusing on the thing that you're good at, so let's say you're working on your facade, you get your facade done for assignment part 1, and you know what you're doing with the facade for assignment part 2, you smash it out, you're done, and your other team members don't do, half the work they need to, and you get like a pass because your team didn't work well. That's not how we're doing it. You smash out your facade, and then because you did the easiest thing, in assignment part 1, you have to analyse the hardest thing in assignment part 2. Okay? So team member 3 passes their work to team member 1. Team member 1 passes their work to team member 2. And team member 2 passes their work to team member 3. And you then have your analytical assignment to do. Okay? What this means is all of you need to be talking with each other about how you're going to be structuring what you're designing and how it's going to be analysed. You've got to think about all of that stuff broad spectrum. Now, there are 3 or 2 of you that don't fit into this because there's no, if I said I want you to go away and do a grasshopper script that makes a facade, you break down, right? It's impossible. Yeah. Now, what I need you 2 to do, so because Patrick's still, is Patrick there? Can someone check the chat, by the way? Like if anyone has any questions, can you just let me know via that chat? Oh yeah, Patrick is there. Patrick Ong? So Patrick, just with a thumbs up because I can't hear you. I can't hear you, mate. So whatever you're saying, I'm not going to be able to hear it. Patrick, you just a thumbs up if you're a civil engineer. He is. Yeah. Okay. Civil architecture. Okay. I need you guys today, the 3 of you, to work out as a team what type of things you want to start analysing and running as spreadsheets that relates to you. Okay? So if you're doing quantity surveying type work, then we need to work out what everyone else in this course is going to provide you because, like if I just take the groups in this room, there's 3 groups. Draw it where you guys can see it. So there's group 1, group 2, group 3. The intention is that we have a engineering architects group that all of this information gets passed to. And you guys are going to do what you do for your other assignments, but we're going to try and automate it. So it doesn't matter if there were 50 groups that are providing their work to you. You only have to set up that system once for that to work. Yeah? Cool. So it's about the system design. It's not necessarily, like the outcome is good. It's going to be very hard for me to judge whether or not your outcome is correct because I don't do quantity surveying and I don't do certification. So, but there's some key things in there. So Danae, we'll discuss this soon, but like the floor plate work, if you want to come up with a system that works out very basic, checking system, like has this been provided? Has 2 lift cores been provided or 2 fire stairs been provided and this number of floor plates, etc., then we can work that out. But I think there's going to have to be a little bit of a discussion between us to work out how we're going to do it. But I'm sure there's something to do. We've got 20 students generating work that can be run through your system. Cool. Okay. So if you're not building the inputs, I am, right? How do I get that to you? And how do we get the computer to understand what's going on? So you look so grumpy, man. What's the matter?
Hey,
Yeah. Just resting grumpy face?
I'm tired.
Okay.
I look grumpy.
Oh, I've just got you sitting in Declan just sitting in the front room. Okay. It's all good, man. Pardon? Don't start shit, Carson.
Yeah.
I'm the only one that's allowed to start shit. Okay. So, if I'm going to send you guys data, like I have to give you guys inputs, right? What's the best way for me to do that? Grasshopper. So I send you Grasshopper scripts. Yeah, you're right. That is the best way because that means you don't have to do any work, right?
I like this idea.
Okay, but think about it. What have we been doing for the last few weeks?
Web thing.
Yeah, right? Right, so web server. Web servers can be storing anything, right? They can store functions that you send requests to and they process. But they can also store, functions, they can also store data. I think, there are some students that are doing that. They're like making web servers that you say, you contact and it tells you the population of the city that you're in. Why that's useful, who knows, but it works, right? That's a database of information and it's returning it. So, you've got Grasshopper, or you've got Excel, or Python, one of those three. All of those three can contact the web server and get the information that they need, right? So if I'm contacting that web server with Grasshopper and asking it, hey, what's the building meant to be? What are the inputs? It's going to return it. What information do you need to start actually making that building? And consider we're starting from scratch, right? Okay, cool. And by the way, I'm going to throw this to everyone, and I want the engineers to answer as well because I want to know what you're thinking of. So you want to know the context. I'm going to use context as really good. It's a really good one though. Okay, so context. Context is going to tell you the limit of your boundary, and that might matter. We are not going to make a system where you guys design a system that puts the best building into that site, because that's really fucking complicated, okay? We're not going to do that. You can do that next year in your master's, in your research thing if you really care about it. I'm going to give you your building footprint. The web people can't see it, but whatever. I'm going to give you your building footprint. Context. What else could exist in context that matters? So
special parts of the site that limit the building.
Yeah. So
easements and boundary and setbacks and stuff like that.
That's yet again we're talking about something that's going to affect the footprint. We're not going to worry about that. But great example. So there are easements and setbacks on our sites. Sometimes architects will say that what they do is not formulaic, but sometimes if you just look at the conditions of the site, this particular boundary of the site is on a major road, so it is set back 20 metres or 10 metres or whatever, and this other site boundary is adjacent to another building. So, in the council that you're in, you're only allowed to you have to be 2 metres off that. And you've got these other things like a thing called FSR, so that's floor space ratio. That's the floor space ratio of the site versus what your buildings is. And that building might be 10 stories. Sometimes there's only one geometry that you can actually really come up with that maximizes that site's space, and for a commercial building, that's what your building's going to look like, right? So we're going to avoid anything that actually affects the geometry of the building because that's too much of a crazy thing to think about. But what are some other things that you might worry about in a building, even though the building's geometry is defined? What else matters? Think about it. When we're in a building, what do we want access to from context? Let's look around the building that we're in right now. What are we getting access to right now?
Well, like front access to the street and stuff, or
Yeah, so where are the streets? That's important. You're right. Now, what do streets generate?
no cars.
What does that create? People? Yeah. What else? That's people. So streets deliver people to your site, right? So that's going to be important because wherever the street is, that's kind of where you want your entry to your building. You know, if your street's over here, you don't put your entry to the building there. Mind you, there are some buildings in Sydney that do that. Don't know why. But what else? What else do streets create? Yeah. Do we want to be looking at streets? What do we want to look at?
The water
Yeah,
view.
views. So generally, there's stuff that we don't want to see or hear, and there's stuff we do want to see or hear, right? So there are positive and negative contextual things, and next week we'll work out a way to communicate that and score it. And it might matter to you, it might not. This is all stuff that's probably going to affect the facade or the plan. It's probably not going to affect the roof. Who knows, right? But if you've got a view of the Opera House somewhere in Sydney, probably want to take advantage of it, right? Because what are we actually here for?
The Opera House.
No, why are you guys at uni? Pardon?
To build the Opera House. Build
No,
something like
you guys are here to get a degree so you can get a job, right? Yeah. And you're getting a job because you want to make money, and you kind of want to enjoy doing what you're doing while you're making that money. And you know, you somehow stumbled on this particular degree or degrees because that's what you want to do to make money in life, or make your parents want to do, or your age wanted you to do it. Whatever, right? Now, why are you getting hired to do that?
Because you're good at it.
But why do they
Because
care
it's
about
cheaper.
you being good at it? Who's
It's
hiring
cheaper
you?
for them.
Yeah, they're hiring you because what are they trying to do? They're trying to make money, right? And if I've got a building that has good views, someone's going to pay more money for that building to rent it to get those views, right? It's all about money, guys. Unfortunately, it's all about money. So we've somehow got to get a building where people get good views, but they don't die in a fire when that building is on fire, right? So there's those two things. People don't want to die on fire, but they also want the good views. They pay more money for the views and they expect the safety stuff, right? So this is actually a really interesting thing, a context on what's going to actually affect your building. But we've forgotten one major piece of data about context. And it's going to change the way your building works significantly. What is the most... Huh?
Where it's like got a service.
Okay, we've agreed, so you're right, but we've agreed that we're only going to do commercial buildings.
Oh, okay.
Okay? So fixed is commercial. And this is sometimes you kind of forget about this in the industry because this is usually a fixed condition when you work on a specific project. So working on a specific project, this will never change. But working from project to project to project to project, this will always change. It will never be the same. What could it be? Think about it.
Like what's within your means, sort of thing?
No.
No.
But yeah, like budget, that changes. But no, it's not that. We're not going to have a budget on this because it's like, but we'll have a quantity surveyor possibly to tell us how much the building's going to cost. Come on.
Maybe who it's for.
Huh?
Who it's for. Like,
No. Most clients are the same. I work for Mirvac, and then Mirvac again, and then Mirvac again, and then I work for Lendlease, and they're just Mirvac in a different skin, right? They're all the same, right? Come on, it's super obvious. No, not a single building shares this with another building. It's completely unique per building.
Location.
Yes, it's location. Thank you. It's super obvious, right? It's something we rarely think about within a project in itself because the location never changes for a project normally. But we're going into a career where we're not going to be working on one building at a time, right? We want to come up with systems that work across buildings so that we can reuse them and save time. And location is a major one, super major one. If I build something in Sydney versus building in Adelaide, that's going to change a lot about that building. Yeah? From a passive design perspective, the sun works in a very different way depending on where you are in the world, right? If you're at the equator, you want to design buildings with big verandas around them because the sun's always going to be really high in the sky. It's going to be coming from all these different angles. If you're in the southern hemisphere, the further you go south, the more you really want to focus on those north-facing parts of the building because they're going to be the ones accessing sun. I find a lot of the students are in China, they're in the northern hemisphere, so that means the sun's actually going to be coming from the south rather than the north. You guys kind of should be learning this in your other classes, but I know you're not. Have you been learning this stuff? What the fuck?
Sun diagrams.
Sun diagrams are done now. The computer does it for us, right? Just remember how you learnt how to do long division in school, right? Do you ever do long division now? Because you didn't have access to a calculator?
No, I didn't.
We have a computer system that will tell us where the sun is based on the location. So what is the best way to describe a location, to communicate it? Exactly. Lat long. So I'm going to give you guys this information, and you're more than welcome to use it or not. Okay. So if you're working in the facade, it is probably best to consider what your latitude and longitude is because it's going to change that. And a lot of the stuff that we're talking about here is about facade, to be honest. But your location is going to determine how solar panels might need to be angled on your roof. Okay? Because there's a certain angle, you should go have a look at it, go look it up if you're doing the roof. What's the best angle? How do we calculate it? It's probably going to be based on the average position of the sun. You guys have learnt about ladybug, right? So you know how to get the sun position off that. Cool. So there's building footprint, context. That's all you guys really need? Yeah? So I've given you the footprint. What else might you need? Does that describe a building? What else do I need to know about the building?
You want to brief?
No. That's not our job at the moment. You do need a brief, but we're making a briefless system. It's a universal system. So what's universally needed to construct a building? Construct's the wrong word. Form a building. Okay, I'll have a building footprint. There's your building footprint. Is that a building? What is it? It's a rectangle, right? So what else do I need?
2 rectangles.
That is a plan. Right, we've got that.
No, it's a stupid joke.
Huh? What?
Another rectangle.
Yeah. where do I draw the other rectangle?
Next to it? Maybe? No, above it.
Like this?
Like surrounding.
Huh?
Surrounding context.
No, forget about context. We're just talking about the building. Come on. How's that a building?
Needs windows. I
Huh?
don't know.
How high up to going?
Yeah.
You need actual floors.
Yes. So, how many floors are there? Floors?
But that's like behind the brick.
Huh? How many floors are there? Is this a 10-story building or is it a 1-story building? Right?
It's dependent on zoning and stuff.
Yes, but don't worry about that. You're getting too deep into it, okay? That if we start thinking about that zoning, we're going to be here for the next 10 years, okay? But good, it's nice that you're thinking about it. How many floors does it have? Now, what's something important as well about floors? Even though we know how many floors there are, does that tell us how tall the building is? So what else do we need to know about the floors? Yeah, and that's called floor to floor distance, I believe. Okay, that's going to tell us roughly how tall our building is going to be, how big it is. It's going to tell us the natural level area and the GFA and all those sort of things. Huh?
Just doing
I'm not intimidating you, am I? Okay. So the web people can't see this. So, much better. So I'm going to send you a footprint. I'm going to send you the number of floors and the floor to floor. And that should give you enough to do this, right? Yeah? That's pretty good. Now,
Can you get that?
huh?
Nothing.
Can you get an A if you get that?
Yeah.
No. Now, I'm going to throw you a curveball, but I'm going to limit the curveball. This is the thing that is the curveball. There's a lot of limitation as to what this can be, right? This is going to be an integer, and it's never going to be 0, is it? And it's probably never going to be like 200, or at least 500, you know? This, you know, in our lifetime, you're laughing. And this is also probably going to be limited. It's never going to be like 1.8 meters, is it? Right? It's going to be a reasonable human dimension. But what could this be? What? Right? It's great. There's crazy level of variation in what that could be. And that's where most of you are going to have to start putting your brain power into. All of this other stuff, it's super limited. But it's this thing that's fucking nuts, right? Because it could be this. How do you deal with placing lift cores in a shape like that versus a shape like this? Yeah? So, we're going to limit this to stop your brains from exploding, okay? But I can tell you now, there are companies out there trying to work out both of those. There's money in it, a lot of money, okay? So we're going to start you off. We are going to limit our shapes to rectangles, L's, T's, and C's. Not Tetris. You don't want to do Tetris, man. It's too hard. It's too hard. Now, you guys can all look at this very easily, these shapes, and you can tell me exactly what they are, right? You can look at this shape and tell me what it is. That's a T, right? So easy. Guess what? Computer has no fucking clue what it is. Okay? And so part of this particular course, and this really relates to geometry, by the way, for the engineers, but I guess there is a tactic to this that matters. This course is about trying to make systems within the computer that can recognize things that humans are like instantaneously able to do. We somehow have to teach these superpowered machines how to actually recognize a rectangle versus an L. So how do we do that? Yeah, I'm going to give Eddie, I'll do Eddie first, yeah? Huh? Probably maths. Yeah, you know most of what you guys do is maths.
I knew that.
You guys have basically been doing like a geometry maths degree for the last 2 years. Like, would you have picked this degree if we told you that's what it was? But you need to be able to do that to then design these crazy buildings that exist, right? Like I'm doing I'm not doing the Opera House, but the Opera House. Like the Opera House isn't feasible unless you understand geometry to its fundamental level and how that relates back to engineering and architecture and all of those types of things. Constructability, like all of those shapes in that building are simple sphere shells that are very easy to set out and construct. And if they didn't do it that way, that building wouldn't exist, right? And so we wouldn't ever have the aspiration. Sydney would probably actually be a very different place if we didn't have that Opera House, but probably be a better place. But whatever. Don't repeat what I just said.
I was about to say, turn shade of the...
Well, yeah, you can never do something better than the Opera House in Sydney, right?
We could.
No, you can't. You wouldn't be allowed to.
Well, you just don't tell them.
They wouldn't, the council wouldn't let you do it.
We just like put it under a top.
The building.
Yeah.
So how are we going to get the computer to recognize those two shapes?
Find someone who worked it out.
Ooh.
Just use that.
You mean like what we did last year? As in, what we did last year, you go find what they did? So I'm going to send you guys polylines. So that's the way that I'm going to send it to you. I could send it to, I could send the same information to the engineers. I just couldn't send it to them as geometry. And that is a little bit of a hint as to how we're going to solve it, right? So just to throw one of the engineers under the bus, just think about geometry for a second. What's different about these two things?
Oh, I know.
Right? What?
It has more sides.
Yeah! How many sides does this have? 4, and how many sides does this have? Right. So we could just say, hey, 4-sided versus 6-sided. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8-sided. Now, the reason I put C in is it's going to fuck this system up, right? I wouldn't have put C in otherwise. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. Doesn't work.
Well, you can just add additional
Conditions, right?
conditions.
Okay, so what other conditions do we have to put in? Let's start turning this into numbers. And Declan, I love your enthusiasm. But go on, what could we do?
Well, you could do it on the terms.
Yes! That is exactly what I was going to try and get this class to think about, and that's how we solve it. But can anyone else paraphrase what Declan just said? So, like Gabby or Rebecca or Carson, what did Declan just say? Rotate it? No, okay. Did you hear? You said base it on the turns. Does that make any sense to anyone?
Yeah.
What? How many? No. The number of points is also the number of sides, technically. They're going to be proportional, +1, right? But I,
Add walls on the little corners.
add walls. Oh no, you're in Eddie's mind. You're totally right. Yeah. Now, what's another way? So, imagine. Okay, I'm an ant walking along this. Walking along. What way am I going to turn? No, I have to stay on the line, right? So I'm going this way. I've got to turn right. Yeah. So what corner is that? That's a right corner. Right. Left. Right. So how would we describe that shape by the number of corners that we take? Yeah. Now I'm going to use a different way of describing right, because you can, if we go that way, it's left, right? It's left, correct. So just geometrically wise, remember, did any of you want to do physics in high school? Year 12 physics?
You could just do it on compass directions instead.
Just wait. I'm sure Ding Wen has an answer for this. How do we describe that shape versus that shape? Yes. This is convex, and this is concave. Yeah? So rather than using right, and unfortunately these both start with the same letter, C and C, so we'll use X versus V, right? So this is just a bunch of X's. What's this? X, 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 V. And then are these going to be the same? They're going to be different, right? Look, you've got two concave corners by themselves versus two concave corners in different positions, right? And so these are effectively ways that we can understand geometry or analyze geometry that a computer system can then read, and we can say, hey, that's an L. And any combination that looks like this, so if we start at this point, as long as it's a combination of that order, it's always an L, right? And any combination of so on and so forth, it's a T or a C. Does that make sense? So, and this is the interesting thing. So when we get to spreadsheet level of looking at a design, and I guarantee you that's most of what most people look at designs is actually in spreadsheets. You might have a door or a beam or a window, and that spreadsheet person only cares about the idea of that window, so that could be window 3, and it's going to have an area, and it's going to have a material or a product type, and that's all they want. Yep, go on.
Could you divide the curves into points and compare their locations to other predefined shapes and compare until they match a predefined shape? It will just rely on having many predefined shapes again.
Yes, so you can do that, but that's not this class. So who said that one? Max. Okay, so Max, the method that you're talking about is basically a machine learning method. And what that would mean is we would have to produce as many possible shapes in a generative environment, and you could just record their positions of the points. Now, just remember, the only reason we're doing this system is to define these two, right? But, you know, there are other shapes out there that you, like this convex concave environment, could start to become, you know, strengths of concavity or convexity, right? 30 degrees versus 60 degrees, and so on and so forth. I think it's 30, 60, right? Possibly. That, like, rather than writing XXX, 30, 60, 30, 60, that is describing a far more detailed shape. And if you guys feel like you need to understand whether or not your shape is more like a trapezoid or a rhombus or whatever, then feel free to delve into this. But we are going to write a grasshopper script to determine how this works. Now, that's not going to apply to the engineers. So in the tutorial, I need you guys to start coming up with what you think you can analyze from what the rest of the office is doing. So just get into a little team and start discussing that while I start. This is the thing, we want to do assignment 1. Maybe we should do assignment 1 first before we start on this. Yeah? I'll answer everyone's questions for assignment 1. So there's no new information in the tutorial until everyone feels like they can finish assignment 1. That doesn't mean me doing it, but it just means me solving problems. And then we'll move on to writing. Like, we actually have to write code that determines this. I have not set up the back end to make this work because I haven't done it. Busy, procrastination, blah, blah, blah. Always do it after it's due. So this will be ready next week. I guarantee it, or at least over this weekend. So you guys will have a hops component that you can connect